As those mini masteries go from last week, I'm gonna see if we have time today or not. Last week was so awkward. We'll touch back in with those if we get a chance. Really, what it comes down to is hopefully you can make probability tables by now. And today we are going to review that and continue to work those skills. In all honesty, I have a headache. I'm not honestly feeling that great, and I don't want to have to speak up. So by the initial gauge, it doesn't seem like you guys are that active this morning. So I don't think that'll be an issue, but just FYI, I do not want to fight with you to talk today. 526. Hopefully we have our plan book filled in. Bless you. Nina's going to buy a fish. Now, the thing is, it's hard to catch the fish in the tank. So you don't necessarily get to say, like, I want that specific fish. You normally just say, like, I want a fish out of this tank. Anyone ever been to, like, Aquarium Adventures over there in, like, off Sawmill? If you haven't been to Aquarium Adventures, you should go. It's, like, an amazing store. They have all sorts of aquariums set up. They have one where you can't even buy the stuff. There's, like, sharks and stuff in there. It's, like, you should go. If you haven't been to Aquarium Adventures, you should go. So Nina is going to go buy a fish, and we are going to determine the probability based off the data given. Now, as we go deeper into the year, sorry, random aside, Casey, here's your book back. We won't make you take the oath. But then this folder is for you to put anything you want back here. I think you left in the middle of us doing this last week or something. Yeah, so I'm actually going to put you in this drawer, different than everyone else. I'm just going to stick you in the front book if you want to clean out your magnifying or and your book is your responsibility. It'll be $77 if you lose it or damage it or whatever. Yeah, book goes, yada yada. So, there are equal numbers of Tetras as there are guppies. And there are also equal numbers of yellowfish, orangefish, bluefish, and silverfish. So if Nina scoops out a fish at random from the tank, what's the probability that she scoops out a silver Tetra? And I know you guys are smart, and a lot of you look ahead. So chat with your group real quick. What do you think the probability that she gets a silver Tetra is? Chat with each other real fast. Can we turn this blue so Greta's not totally backwards, so we're all kind of looking sideways. So you guys can get these real quick. I'm going to turn this up 90 degrees. So turn everything this way. You see what I mean? You guys just have to turn a little bit out. You guys just have to turn a little bit as opposed to anyone being totally backwards. All right, and we are back to our regular schedule, and I need to hold myself accountable to using cards again, because last week we kept talking about that, but I had awkward groups and like twice you at the same time. So, Aiden's not here. Joey, what do you think? What's your probability? How do you figure? It's on the chart. Now, do you agree with that? Because that's the chart that she made. Alana, can you give us anything else? No. You had a lot of people sick today. Kevin, can you give us anything else? I don't think so. Alright, so if you went ahead and looked at Part B is probability table, right? So she listed out, instead of two different events happening, there's, well, still, we could kind of call them two different events. We're going to choose a type of fish and choose a specific color. And if there's equal distributions of each, then this table works. Now, so Nina looks at the table and says, so everything's 1/8. I think I can get that by 1/4 times 1/2. So if we, and let's go ahead and throw this on our notes. I'm actually going to switch screens real quick. If we talk about the probability of a silver tetra, let's just go ahead and write P of ST, so like silver tetra. So in your notes, you should have a header. But then if we say probability of silver tetra, we said is 1/8, and Joey just said it's because Nina's smart.
That's my assumption.
That comes from 1/4 times 1/2. Because we have 4 of what? 4 colors, right? That's actually not the types of fish, that's the colors. So we have 4 colors, 2 fish types. So the way that we can calculate any of these probabilities is math just like this. So look at the next problem. As we get deeper into the year, guys, I'm hoping to do less and less and have you guys kind of driving the class or guiding yourselves through. If we look at the next problem, 77, chat with your team about that situation where now we're going to have like marbles in a bag, something like that. Cubes, but same idea. So we have 2 blue cubes, 1 yellow cube. Go ahead and sketch on your notes what you think is accurate. You have 2 different probability tables here given to you. Which one do you think makes sense? So take a moment, chat with your group. So the real question we're trying to answer here is what's the probability she draws a blue and then another blue? What's the probability she draws a blue and then another blue? I'll give you about 30 more seconds to wrap up your conversation on what's the probability of a blue and another blue, and then I'm going to random card for somebody to help me. Oh boy. What up? Good morning. That's not a pass from the office. That is definitely Miss Warren's handwriting. So, Skylar, your card's on the top of the deck. What do you think the probability of blue and blue is? So if you are in your notes, you could just say like B and B. If you want to make life easy, P of B and B by probability of. Skylar, what do you think?
4 9.
How did you get 4 9s?
Because since he is like trying to, I don't know what I was doing with that, but so I drew a graph and like that one.
This one?
Yeah. And then since she pulled a cube out and then put it back, and then she drew another one, I like did that. She did it twice, and then I did it 2 times 2 because there's 2 blues, and then yeah.
Yeah, it doesn't matter which blue we get, right? We just want probability of a blue and another blue. Which there's more blues than there are yellows. But how's 4/9 compared to a half? Is it better than a half or less than a half? Less than a half, right? Because what we're looking for is that to happen twice in a row. So even though there's 2 blues and getting a blue is your biggest chance, probability of getting 2 blues, 4 out of 9. Now what if I ask you what's the probability of getting a yellow and a yellow? 1/9, right? Because we'd be looking at this section, and that would be 1 out of 9. Now, can anyone speak to Edwin's table up here? What do you mean, Isaac? It has fractions. So you said Edwin's table's broken, and I agree with you. It kind of looks wrong, but it's not quite broken. On our graph paper, we'll be able to draw Edwin's table the right way. So please make sure that you have this table, the one that we were just looking at, the one that I was highlighting. Please make sure you have that in your notes. But then write in your notes, area model probability. So area model for probability. Here's what Edwin was trying to do. Edwin was trying to use the space that things take up to actually show the probability. I'm not a cafe. I'm a math class. If you're going to eat, you've got to do the math. Here's what Edwin was trying to do. He was trying to take the table that he had and simplify it by saying, well, 2 out of the 3 are blue, and 2 out of the 3 are blue. So instead of saying blue, blue, yellow, he was just going to say blue takes up both of these, and yellow only takes up 1. Blue here takes up both of these, and yellow only takes up 1. If we draw it using the right size, which he wasn't on graph paper, so it's kind of hard to see, notice how his blue section is much wider than his yellow section. Now, it's the vertical part that I kind of have opposition with, that I will agree with Isaac that his table is broken. But if we make our vertical section bigger, notice based on area, my blue has 4 out of the 9 squares. My yellow has how many squares? 1 out of the 9, right? How many squares, or what's the chance of getting a yellow-blue draw? What if I don't care about order, but what's the chance of getting a yellow-blue? Careful. There's 2 different sections, right? So, this section, I agree with you, Ava. That section's 2 out of 9. But if I don't care about the order, I have another section that's 2 out of 9. So guys, you're going to be using CPM's curriculum for the next 4 years of your math career. The area model is a huge piece of CPM. So us giving things the amount of size that they deserve based off, in this situation, chance, right? We're giving it more size because it has more of a chance. We give it less size because it has less of a chance. Does this make sense? How we give it 2 blocks versus 1 block? I still see pencils moving, so I'm also just kind of trying to use up some time. All right, so we move on to 78. Oh, I should clear this off. I'm going to turn my projector off for a second and turn it back on because it's really loud. I think something's wrong with the fan. If you guys at your group, you should have your book. If you can check out 78. Here, take a moment to read it before I turn the projector off in case you don't have your book. Yeah, you can use those. You just have to make sure you put them back in the class. It wants you to set up an area model. Actually, I'll throw it up on the TV. I can turn the projector off and keep this up. Use your graph paper. Build an area model. And it just says food first. There's other food options.
Oh, I thought you just pressed back.
You can, but there's other. And it depends what kind of snake. I think certain types of snakes are vegetarian. But I could be totally wrong.
I didn't know that. I think that's true.
Guys, we should be building an area model to represent our food. Three by cat, two by dog, one by snake. How many people total buy food? 6. It doesn't matter how tall your table is, but I would make it 6 wide. Now, for the table height, I would make it an even amount of boxes because that's going to be my cash versus credit. How many people buy cat food? 3. So when I go to do that, my C gets 3 of the boxes wide. How many people buy dog food? 2. It gets 2 of my boxes. And then my last one is snake food. Cash, I'm going to make a $. And then credit card, I'm going to make CC. And split that in half. That's how we're going to use the area model to solve this problem. Now here's the dangerous thing. The chance of somebody buying cat food with cash is not 1 out of 6. I need your group to figure out whatever probability you want to choose. But if I call on you, you need to be able to give me a probability from the table. Okay? The probability of cash is not 1 out of 6. Right? It is one of the 6 boxes, but it's not 1 out of 6. So go for it. With group, determine the probabilities of whatever you want to, but write it down. Okay, so probability of cat with cash, not 1 out of 6. Start drinking coffee for senior year of college. What do you mean you have no
My
idea?
favorite is
So it's bigger though, right? So this is why we're using the area model. The area model, as opposed to giving it two different boxes, puts it together. Now, if we want to split these, we could. So one thing that might help some of us is that if we wanted to split these, we could. And make them all the same size. So then I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Right? I have 12 different boxes, but they're not all different actually. These 3 are the same. These 3 are the same. Those 2 are the same. So when we look at the probability of buying cat food with cash, excuse me, it has 3 of those rectangles, or 6 of the squares, if you want to say. So if I make it 6 to count every box out of 7, 8, 9, 10, 11, 12, 24.
How does it get a 24?
Or 3 out of 12, or 1 out of 4. Reduced down, that is 1/4 of a chance that somebody would buy cat food with cash. Because it takes up, if we just think literally, it takes up 1/4 of this box. Look at it, guys. This splits it in half. And this splits it in half. It takes up 1/4 of the box. Now, if we look at, let's see whose card is up. Natalie, I asked you guys just to determine whatever probabilities you wanted. Did you determine one that was not cat food with cash?
Yeah.
What'd you figure out?
It was dog food with cash.
Dog food with cash. What was that probability? It is not 1/4. So, everyone on your paper, please write with us P of dog food with cash. Let me get bigger. Now, on my table, it takes up 4 squares. Right, if I count by squares. Out of, we know what's the total? 24.
Did I say 1/4?
Yeah, you did say
I
1/4.
did not.
What'd you mean?
I wrote down 1/6.
It's 1/6. When we reduce it from 4 out of 24, or you might have 2/12, but we get 1/6.
I get the C. You don't get the D.
What about it? Give me more.
So you said 4 out of 20. How is it 4 out of 20?
So So we split this to be, these are the 3 cat food purchases. These are the 2 dog food purchases. This is the 1 snake purchase, right? The width that we gave it. And then half paid cash, half paid credit card. So we just split it in half. So then when we look at dog food cash, 1, 2, 3, 4 of my boxes out of a total of 24. If I use the size of the table. Now the other option here, make a table like this, but cat, 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 dog, dog, snake. Well, so this should actually be in the middle. But so the other option is cat, 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 dog, dog, snake. But instead of doing that, we could just merge these 3 cats together and then make it bigger. Does that make sense? Because we connect these boxes. We leave it split between cat and dog. We connect the dog boxes, and the snake doesn't have any connection.
Oh, so you're connecting the snap. Oh.
Does that make sense?
Yes, because I was like,
But this split is in the middle. I drew that in the wrong place. This split's in the middle, but you get what we're doing. Instead of having 3 different cat areas, we put it together, but it's bigger.
Oh, so it's like.
Whoa, okay, I get it.
Oh, okay.
Other questions?
Wait. So cat. So when you bring the other cat, how is it not? Then it's 1, 2, 3, 4, 5. The actual two from the D and the D. And
Those are dogs.
Yeah, those are really good.
Oh, right, because there's not. Oh, okay, sorry.
Yeah, because we were asking, like, now dog and cash, that only gets 2 of those areas. But if I count by squares, how I made it up here, I got 4.
You
I only made it bigger to
You put
fit my
cash,
range.
cat. I was like,
Yeah.
what is the extra C?
Yeah, sorry. Other questions on this? Alright, I want to play a game.
Yay.
Now, here's our game. Right? 79. Your team is against me. Okay? Now, spinner A has the numbers 2, 3, and 4 on it. Spinner B has 6, 7, and 8. Here's the rules. So your team, hopefully you're reading, because I'm not reading everything out loud. Your team is going to have to choose even or odd. Right? You have to choose even or odd. With your team, I want you to determine which you choose. Are you going to pick even or odd?
Alright, kiddos, are we going to do even or odd? Dad says that whenever he's mad at me.
You could use a probability table to help figure this out.
But there's 2 odds and 4 evens. Wait, I think one counts. Yeah, and he counts it. I really thought it was.
Oh, no work. Guys, we should be making a probability table for this situation to make your bet. Probability table to justify it. So you should be able to tell me what's the probability of even and what's the probability of odd and which has better chances. If I go fill in my sums, that's going to take addition. So, Layla. Oh, yes. What would you choose, even or odd, and why? Why?
Because there are more even numbers than there are odd numbers.
So what's the probability of even? You can help. You can help her.
All of them, even the ones on the outside? No.
I have obviously failed as a teacher. I would have sit
Yes,
here.
you have.
So Riley, can you help explain to Layla why we wouldn't use the numbers on the outside?
Because they're not the numbers. Well, I mean, they're not all even. That's what I said. And they're not in the box.
What is the in the box? What's the difference between those and these? Casey, what do you mean about these are the sum? What does that
If
mean?
you add the numbers together, you get the sum, and the sums are on the inside. That's what we care about.
The result is what we care about. We don't specifically care about spin 1 or spin 2, but we care about what they make together. So if I look at the evens there, 1, 2, 3, 4, 5.
I said that and they said I was wrong.
So the probability, please make sure you have this on your paper, is 5 out of 9. Now I hope that you have that on your paper, but I gotta admit something. I'm kind of a cheater.
Called it.
I'm calling the FBI.
So these spinners, draw squiggly, cross your notes, draw squiggly. You're assuming that these spinners are fair, right? That these are equally chanced. Did I tell you that they're fair?
No.
So actually, that's what the spinners look like. So now, with your group, and this is the last thing we're doing today, which means you should have like 5 minutes for homework here when we get done. With your group, now determine where you should bet. Even, or now it might still be even. Might. But with these probabilities, determine what your bet is. So, this spinner is fair, right? This one's equally split up. What's the chance of getting 4 up here?
1/8.
Chance of 2?
1/8.
Chance of 3?
3/4.
No.
I would use an area model if I was you.
Oh yeah. These are all 1/3.
Should we
Your new table should be 8 by 3, or you can make it 6 tall, or you can make it 9 tall. I'm just going to make it 6 by 3 to make your life as easy as possible. Or, sorry, 8 by 3. Sorry, make it as easy as possible. What's your best chance on the first spin? 3, right? Because 3 takes up 6 out of the 8. Now, we don't actually need to write 3 6 times. No, you could. Quit being angry at me.
I'm stressed.
You're overreacting.
That's Layla.
3 gets that much of this because it has that much chance. 2 and 4 have much less of a chance. But then 6, 7, and 8 are evenly distributed. So we have 6, 7, and 8. So the sum here is 9, right? 6 plus 3. Because I don't really need the 3 written 6 times, but if you need to help your brain with the area model, you can. My sum here, 10. My sum here, 11. 8, 10, 9, 11, 10, 12. Right? Yeah, somebody check my math, make sure I'm not crazy. So now, if I look at probability of even, well, yeah, I have 1, 2, 3, 4, 5 even numbers up here. That doesn't make that my probability. How many squares do my even numbers take up? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Out of how many total squares there? Ooh, wait. So is even my good bet now?
No.
Let's look at odd. Now odd should be the rest, right? But odd is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. So the probability of odd is now 14
Because 3's an odd number.
out of 24.
And plus 3, they have much bigger space.
Because 3's the odd number, and it has a bigger space, that makes the odds have a lot more chance of happening. Any questions? You have the next 4-ish minutes to work on your homework. And I will put it up here on the screen in case you don't have a book in front of you.